So in the previous lecture, we have learned how we can define the static earthquake load cases, how we can define the wind load along all the four directions, and how we can define the self weight. So now in this lecture, we shall learn how we can define the dead loads and how we can define the live loads. See, dead loads are nothing but just a simple math that we need to calculate the density of material, and then we need to multiply that by the thickness of that, and then we can apply the equivalent UDL on that. Live load is something that is guided by the codes. So for example, if you are referring the loading for the American standard, you need to refer the ASCE 07. If you are referring to the Indian standard, then you need to refer IS 875 part number 2 for the live loads and part 1 for the dead load calculations. So dead load is nothing but just a simple math, and then we can take a simple example here. So for example, if we want to, this was our first floor plan. So on this first floor plan, we have some brick walls over here, and we have some partition walls over here. So for example, considering all the brickworks are of 9 inches thick, that is 230 mm thick, then how we can calculate the loading of the brick wall on the beam? So what we need to do here is that, let us say the height, we first of all need the height of the brick wall. Now if we refer to our sections here, the floor height is in the range of 3.5 meter. So considering the height of the beam is 450 mm, so what we can say here is that the height of the brick wall is 3.05 meter. After that, the density of the thickness of the brickwork. Thickness of the brickwork is nothing but 9 inches, so we can refer here to 0.23 meters. After that, density of the brickwork, it is 19.2 kg per meter cube, 19.2 kilonewton per meter cube. So if we want to calculate the UDL, so we need to multiply all the terms here, that is 3.05 into 0.23 into 19.2, so it is 13.47 kilonewton per meter here. After that, we need to calculate the thickness of the finishing also, that is the thickness of the mortar on the brickwork. So let us say we are applying 12 mm plaster on both the side, so it comes out to be 0.024 meter. Density of the mortar, it is in the range of 24 kilonewton per meter cube. So height of the mortar is same as the brickwork. So the UDL is coming out in the range of 0.024 into 24 into 3.05. So the weight of the mortar is approximately 1.76 kilonewton per meter. So total UDL is nothing but 1.76 plus 13.47. So 15.3 we can take that on the conservative side. So 15.3 kilonewton per meter is the UDL. So going back to our model here, so in this model, here we can see that on the grade slab, we shall not apply loading of the slab, so we shall only apply the loading of the brick wall here. So all the external partitions except for this one, the brick wall is coming, or except for this one. So we start from this grid here. So on this grid, from this point to this point, the brick wall load is coming. So we go to dead load here, left click on member load here, uniform force. Here we can enter this particular value, that is 15.3. So minus 15.3 kilometer per meter. Let's select the global direction as GY. Left click on add here. So we can select all the beams here. Left click on assign to selected beams and yes. So now we have applied the loading of the brickwork here. And after that, the profile is rotating like this. So we do need to apply the brickwork loading here and then along all the all along from this point to this point. You should notice that like we are applying a door here, so we can take the brick wall on the conservative side. But if like I have seen some engineers who are very typical about all these things, so what they do is that they apply brick wall loading from this point to this point and from this point to this point, but in the meantime like they don't apply the loading of the door here. So although door is a light material, so but if you are like doing that much amount of calculation, then you do need to do this small calculations also. So this is just like my recommendation. My recommendation is always like always go for the conservative side. So there is no harm in like going for that. So selecting this beam here, then this and then this. So now we can select the beams here, and after that from this point to this point and all along this point. So although there cannot be a brick wall here, so what we can do here is that we can apply loading from this point to this point. So taking the beam here and then here. After that, we do need to apply dead load for a particular length here. So the beam starting point is from left. So what we can do is that we can go to member load, uniform force, this minus 15.3, and then we can select that from D1 0, the D2 is only from this point to this point, so approximately 2 meters here. So we can enter D2 as 2 meters here. So let us see that whether this nomenclature is correct or not. What we can do is that we can go to tools, redefine incidence, and switch incidence of selected beams. So here we can see that now the loading is correct. So after that 1 2 3 4 1 2 3 4 5 6 and 7. So 1 2 3 4 5 6 and 7. And after that, here we can see that only there is an opening here, and then after that we do need to apply 1 2 3 4 5. 1 2 3 4 and 5. Similarly, there is an opening here, and we do need to apply the brick wall loading on these two beams also. So after that we move on to the interior beams. So all along from this point to this point we have this brick wall loading. So what we can do in this case is that we can select all the beams here. So now we applied the brick wall loading on the interior beams also, and then after that 1, 2 and 3. So 1, 2 and 3. While selecting beams, make sure that no column is selected. So cause some people, what they do is that while selecting the beams in the plan, they also select this column, and accidentally they apply the loading on this column also. That is a wrong practice to do. So always take care of what you are selecting, and after selecting, it is recommended that you should also check that in the isometric view. So every alternate beam is now loaded. So 1, 2 and 3 and 4. So 1, 2, 3 and 4. After that, again you can see that this brick wall is also existing here, and then this brick wall is also existing here. So what we need to do is that we need to model a beam for this particular brick wall also. So the approximately distance is in the range of 0.475. So we can model a beam at an offset of 500 mm here. So we select this node here and select Z as 0.5 meter, and go to geometry, add beam by perpendicular projection. So now this beam needs to be released on both the ends here. And while applying the loads, you need to have a 1 brick thick wall loading here. And similarly, when we are checking this arrangement here, so now we need to apply brick wall loading on this particular beam also. So now we can check that we have now applied all the brick wall loadings except for this particular frame here. So 1, 2, 3. And 4. After that, we need a beam for this particular wall also. So we can go to geometry, add beam between midpoints option. So we can apply a loading on this particular beam also. So now we can check that we have applied loadings on for all the brick walls here. And as discussed earlier also, we don't need to apply a slab loading on this particular floor, as this is resting on the ground. So after that, we move on to the next floor here. So all these particular floors are typical here. Here we can see that we have not did a mistake here. As I was discussing with you earlier also, that if we accidentally select the columns also, then the loading looks like this. So we can left click on toggle load and left click on assign to selected beams. So with this we can toggle the 15.3 kN per meter vertical loading on this particular column here. And after that, as discussed earlier also, that the loadings on all these floors are typical. So we can select all the floors simultaneously, and then we can apply the loadings on all the 3 floors by selecting all the 3 beams in a single plan view, thus saving time. So we select go to the second floor plan here. So here we can see that every alternate beam is loaded with full brick thick wall. So we can select all the beams here, and then this particular beam and this particular beam. So before that, let us check that height is same or not. So here we can see the height is same except for this particular floor. So on the top floor, we do need to apply the lesser loading, but conservatively, to explain you the concept, what I am doing here is that I am taking the loading on the conservative side only. So if you are designing that in the real life, so what you need to do here is that you need to take the lesser height here, and then accordingly calculate the load and then apply the loading on the top floor. So to save the time, what I am doing here is that I am applying as loading on all the floors, as considering the height of the brickwork as 3.05 meters. So checking that in the 3D view, so now we can see that all the beams are selected here, and after that we do need to go consider the profile like this. So as a common sense, we can see that all the perimeter beams are now covered here. So what we can do here is that select all the periphery beams and apply a loading of 15.3 kilonewton per meter here. So now we can see that we have now applied the loading of 15.3 kilonewton per meter on all the peripheral beams. And after that, we do need to see here whether there are some extra walls here also. So for that, what we need to do here is that we do need to select all the beams from this point to this point and apply a loading. And after that, these two beams here, and 1, 2, and we do need to apply loading on these two beams also. After that, 1, 2, 3, 4, 5, and 6. So 1, 2, 3, 4, 5, and 6. In real life, what I do is that I take a printout of all the architectural drawings, so that I don't need to switch to and fro between the CAD drawing and the Staad model. So that practice also helps us in saving me lots and lots of time, because I don't need to switch windows when I'm having a printout in front of me. And now we have applied the brick wall loading for all the floors. And for parapet, what we can do is that we can just calculate the loading for the parapet on the top with 0.9 meter height. So what we can do here is that we can just copy paste this particular calculation here. Instead of 3.05, we can select 0.9. So the parapet loading is coming out to be in the range of 4.5 kilonewton per meter. So we name a dead load case here, and for member load we can enter minus 4.5. So now we have assigned the parapet loading on the top as minus 4.5 kilonewton per meter. So with this approach, now we have calculated all the dead loads except for the staircase loadings. So here we can see that staircase dead loading needs to be considered here, and the dead load due to slab also needs to be considered here. So considering the spans are very short, in the range of 3.5 to 4.5 meters only, so we can take 150 mm slab comfortably for this type of arrangement here. And the slab is also two-way here. So here also we can see that this span is also two-way span. So what we need to do in this case is that we do need to define the groups also. So what we can do is that we can select all these floors here, for which we do need to define a group here. As all these floors are typical, so that is why I'm defining the group in a single go. So we refer to the architectural drawing here. So here we can see that for for corridor the live loading is different, for classroom the live loading is different, and for these washrooms area that we are seeing here, the loading is again different. So in the next lecture, we will learn how we can calculate the dead load due to slab and how we can calculate the live load for different type of rooms and different types of arrangements.